with Algebra 2.2, solving inequalities, specifically using addition and subtraction. So before we start solving inequalities, you need to be able to solve equations because you solve inequalities almost identical to solving equations. You still want to use inverse operations on the variable, which means you still need to see what's being done to the variable. Whatever you do to one side of an inequality, you have to do to the other. So there's quite a few similarities when you're solving inequalities as solving equations. There is one golden rule for solving inequalities that we'll actually talk about in the next section, 2.3. But when you're solving an inequality, make sure you read the directions because basically for every inequality that we solve, we'll graph it as well. So if I just read this inequality, x minus 3 is less than negative 4. It kind of works out nice that the variable is on the left, so that should actually make it easier to graph. But what's being done to the variable is you're subtracting 3. So similar to an equation, the inverse operation is adding 3. We add 3 to each side. We're left with x on the left side. We keep the inequality exactly the same, less than. Or another way to think about it is inequality points to the left, it's going to stay pointing to the left. Negative 4 plus 3, negative 1. Then we can graph that. So I want to make my number line, put 0 in there, and then negative 1. So x is just less than negative 1. There's no equal to sign here, so we want our open or non-filled in circle at negative 1. Like I went over in 2.1, the variable is on the left side of the inequality here. So the inequality points to the direction that you're going to shade your solution set in. Okay? If x is less than negative 1, all the numbers to the left of negative 1, not included, including negative 1, shown by our open circle, are less than negative 1. For example, negative 3, even though I don't have that number listed here, negative 3 is less than negative 1. Okay, for our second example here, I want to solve the inequality for p. If you notice, p, the variable is on the right side of the inequality. So I'm actually going to put it on the left once we do solve it. What's done to the variable here is 5 is being added to p. So the inverse or opposite operation is subtracting 5 from each side. Negative 3 minus 5 is negative 8. If I'm going from left to right, I read it as negative 8 is greater than p. And then, especially to help me graph it, so I actually don't want to use this inequality with the variable on the right to help me graph it, because this inequality points to the right. That's actually not the way that I'm going to make my arrow on my graph. So what I'm going to do here is write an equivalent inequality. Negative 8 is greater than p would be the same as p is less than negative 8. These two inequalities really say the same thing. If you notice in the first inequality, the inequality is pointing to the variable. So once I switch things around to put the variable on the left, the inequality still points to the variable. And now I can graph that. Here's 0. I'm going to go by 4s on my graph. And then negative 8 would be to the left of 0. P is less than negative 8. So I want an open circle at negative 8. I make it like that. I think it's obvious that it is an open circle at negative 8. And then my arrow is going to go to the left. All the numbers to the left of negative 8 are less than negative 8. So that's the graph. And if I wanted to name a solution could be something like negative 12. Negative 12 is less than negative 8. Okay, for this next example here, I'm not going to write out all the directions, but again, solving an inequality is like solving an equation. So if possible, you want to try to simplify each side of the inequality in this case. Let me also mention, when you're solving an inequality, if you start with an inequality, like I do here, greater than, okay, then you have to end with an inequality as well. You can't start with an inequality and then somehow make it an equation. Okay, but what I notice here on the left side of the inequality, we have some like terms, negative 7m and positive 8m. So we can combine those like terms. Negative 7 plus 8m is 1m or just m. I could actually write it either way. And then on the right side, we have some like terms as well. 15 minus 2. So 15 minus 2 is 13. And then we could just use inverse operations to isolate the variable. What's being done here to m is you're adding 15, so the inverse or opposite operation subtracting 15 from each side, m is greater than, and then on the right side, 13 minus 15, negative 2. I know all the examples we didn't have an equal to sign underneath the inequality. If you do, how that would change the graph is you would just put a filled in circle, or that also means that the number is included. Okay? But here I have negative 2 on my graph, put in 0 as well. So negative 2 is to the left of 0. Since there's no equal to sign underneath the inequality, they can open or a non-filled in circle. M is greater than negative 2. All the numbers that are greater than negative 2 are to the right of negative 2. Or again, since the variable is on the left here, inequality points to the way that you should make your line or arrow on your graph.